In the farthest regions of the solar system, there is a world that looks like it belongs to another era. Its path runs through regions of space where almost no solar heat reaches. There begins the kingdom of eternal night, where time flows differently, and distances become so enormous that the usual scales cease to matter. Among the many icy bodies hiding behind the orbit of Neptune, it is Sedna that remains one of the most mysterious objects. It is moving along such an unusual trajectory that its existence still raises questions about the past of the entire solar system. As Sedna approaches the Sun, it is separated by tens of billions of kilometers of emptiness, but she spends most of her journey much further. At the most distant moments of its orbit, Sedna is so far away that the Sun turns into only an exceptionally bright star among many other stars. Light takes many hours to travel this distance. Temperatures drop to values close to absolute zero, and the surface remains almost unchanged for millions of years.
Sedna is one of the trans-Neptunian objects, but even among them, it looks like an exception. Its orbit is incredibly elongated. One complete revolution around the Sun takes about 11,000 years. As civilizations change on Earth, continents slowly change their position and new eras emerge. Sedna barely begins the next stage of her movement through space. The very origin of such an object remains one of the main mysteries of the outer solar system. Most known bodies beyond the orbit of Neptune are noticeably influenced by giant planets. Their trajectories can be explained by gravitational interactions that occurred in the past. However, Sedna's orbit is too far away for its shape to be fully explained by the influence of known planets. There is a feeling that once it was affected by a force that is now absent or hidden from observation. One possible explanation takes Sedna's story back to the earliest stages of the solar system's formation. At that time, the young sun could be among many other stars, born in one giant cloud of gas and dust. The distances between neighboring stars were then much smaller than they are today. If any of them passed relatively close, its gravity could distort the orbits of distant icy bodies. As a result, some objects were ejected into interstellar space, while others ended up on unusual trajectories similar to the orbit of Sedna. If this version is correct, then Sedna may keep traces of events that occurred more than 4 billion years ago. It becomes a kind of witness to an era when the modern architecture of the solar system has not yet been fully formed. Its current situation turns out to be not an accident, but an ancient imprint of the processes that took place during the birth of planets.
There is also a more mysterious possibility. Some features of the orbits of distant objects hint at the existence of another large body in the farthest regions of the solar system. Such a hypothetical planet remains undiscovered, but its gravity could explain many unusual characteristics of the motion of Sedna and other distant worlds. If such an object does exist, then Sedna may be one of the first keys to finding it. The surface of Sedna is also of great interest. According to available data, it is covered with a mixture of water ice, frozen methane, and complex organic compounds. It is these substances that can give the object a characteristic reddish tint. Under the influence of cosmic radiation, simple molecules gradually turn into more complex structures, forming dark organic materials that can persist for billions of years.
The appearance of Sedna tells the story of the continuous impact of the space environment. There is no atmosphere here in the usual sense.
There are no processes that can quickly renew the surface. Every impact of a micrometeorite, every particle of high-energy radiation leaves traces that can persist for an incredibly long time. As a result, the surface becomes a kind of archive of the ancient history of the solar system. Of particular interest is the question of the internal structure of the object. Despite the extreme cold, some models allow for the existence of areas deep below the surface where ice may be in other states. The internal heat left over from the time of the formation of the body, as well as the decay of radioactive elements, are able to support slow processes in the interior. Although the probability of the existence of liquid layers is considered small, this possibility cannot be completely ruled out yet.
The further Sedna is studied, the more it blurs the familiar boundary between the Kuiper belt and the much more distant Oort cloud. This object seems to occupy an intermediate position between two huge regions of the solar system. Some researchers even consider Sedna as the first known representative of the inner part of the Oort cloud, an area that remains largely unexplored. If this is true, the significance of Sedna becomes even greater. It may be only the first discovered object of a huge population of worlds lurking in the farthest vicinity of the Sun. There could be thousands or even millions of icy bodies moving in gigantic orbits and completing one revolution in tens of thousands of years.
Such a perspective changes the idea of the size of the solar system. The world, which is usually associated with the orbits of known planets, turns out to be only a small part of a much larger structure. Beyond the usual borders, a region begins that is still almost unexplored and can hide many unexpected objects. Sedna's future looks as unusual as her past. Over the millennia, it will gradually move away from the Sun, sinking deeper and deeper into the cold darkness of the outer solar system. Its movement is so slow by human standards that changes in position are almost imperceptible. However, on the scale of cosmic time, Sedna continues its endless journey through a gigantic orbit, preserving the memory of the oldest events in the history of our star system.
This is its main mystery. Sedna looks more than just a distant icy world. It resembles a fragment of an epoch when planets were formed, orbits changed, and the future structure of the solar system was determined. Each new fact about it gives rise to new questions. Why is its orbit so unusual? Are there other similar objects? Was there any influence from a passing star? Or is there really another large world hidden beyond the boundaries of the known planets? While the answers remain unknown, Sedna continues to move through the silent spaces of the outer solar system. Amidst the icy darkness and colossal distances, it remains one of the most mysterious objects ever discovered near the Sun. An ancient messenger from a time when the history of our cosmic system was just beginning its journey. But the most intriguing questions begin exactly where the known facts end. Sedna is so far from the main planets that the usual mechanisms of orbit formation begin to work worse. Every attempt to explain its current situation faces serious difficulties. If the object had formed where it is today, the birth process would have taken too long. The density of matter at such distances was extremely low, even in the younger epochs of the solar system. Ice and dust simply wouldn't have time to gather into a large enough body before the surrounding matter dissipated. This means that Sedna could have appeared significantly closer to the Sun and then been thrown into its current orbit. But here, too, there's a problem.
None of the known planets is capable of moving an object to such a trajectory efficiently enough. This requires a very specific gravitational effect. Too strong an interaction would eject the object from the solar system entirely. Too weak would hardly change its path. Sedna's orbit looks like it has experienced an extremely rare event that will never happen again.
Some models suggest that there was a period of real gravitational chaos in the early history of the solar system. The young giant planets changed their orbits, moved relative to each other, and repeatedly redistributed the matter of the outer regions. In such epochs, billions of icy bodies collided, collapsed, and were ejected over vast distances. Perhaps it was then that Sedna got her unusual route. However, even the most complex models do not yet give a definitive answer. Its size remains no less mysterious. According to modern estimates, the diameter of Sedna is about 1,000 kilometers. This makes it one of the largest known objects outside of the orbit of Neptune. Although it is significantly smaller than the dwarf planet Pluto, its size is large enough for its own gravity to give it a near spherical shape. It is no longer just an irregularly shaped ice block, but a full-fledged world with its own geological history. Sedna's surface may appear relatively calm, but behind this external immobility lies a long evolution. For billions of years, cosmic rays have continuously bombarded its upper layers. High-energy particles break down ice molecules and create new compounds. Over time, the surface darkens and acquires a rich red hue. This process is so slow that the same patch can remain virtually unchanged for epochs comparable to the age of the solar system. Especially interesting are the seasonal changes that can occur on Sedna. Despite its monstrous distance from the Sun, its highly elongated orbit leads to a noticeable difference in the amount of energy it receives. As an object gradually approaches the interior of its trajectory, some frozen substances are able to partially evaporate. Then, as they are removed, they settle back to the surface. These processes are extremely slow and can stretch over centuries and millennia. Perhaps Sedna looked different in the past. In the early stages of the solar system's existence, the number of collisions was much higher. Large impacts could change the shape of the surface, create huge craters, and even temporarily heat internal regions. Traces of such events can still be preserved, hidden under layers of ancient ice and organic compounds. But even more surprising is that Sedna may be only the tip of a huge unknown population of objects. Its discovery showed that the outer solar system is much more complex than previously thought. If one such object exists, then there must be others. Over time, additional distant bodies with unusual orbits were indeed found. Some of them move along trajectories that look suspiciously similar. This is where one of the most talked about space mysteries of recent years begins. The orbits of a number of distant objects show a certain orderliness. Instead of a random distribution, they seem to be influenced by a single gravitational source. This picture gave rise to the hypothesis of the existence of a massive, unknown planet far beyond Neptune. If such a world exists, it could be hundreds of astronomical units from the Sun. Its orbit could take thousands of years, and the surface temperature would be incredibly low. Such an object hardly reflects sunlight and remains extremely difficult to detect. In this case, Sedna becomes a kind of directional indicator, a trace of an invisible force that continues to influence the outer regions of the solar system. However, there is another possibility.
Some calculations suggest that unusual orbits may be the result of the collective influence of many small bodies distributed over a huge volume of space. Instead of one giant planet, the cause may be an entire region of hidden mass which cannot yet be observed directly. In such a scenario, Sedna turns out to be part of a much larger structure. These questions go beyond the study of a single object. They touch on a fundamental understanding of how star systems form. If the history of Sedna is indeed connected with the close passage of another star in antiquity, then the early stages of the Sun's existence may have been much more dynamic than previously thought. If the cause is an unknown planet, then the map of the solar system still remains incomplete.
With each new observation, it becomes obvious that the boundaries of our cosmic home extend much further than usual notions. Beyond the orbits of known planets begins a region that remains almost unexplored. Ancient ice worlds move there, preserving information about events that occurred billions of years ago. Among them, Sedna occupies a special place. It is located at the crossroads between the known solar system and a vast region that is still hidden in darkness. And perhaps Sedna's greatest secret is not herself. Perhaps its true meaning is that it indicates the existence of something even larger, something that still remains invisible among the vast spaces beyond Neptune. And as Sedna continues its slow journey through the icy abyss of space, this mystery remains open, waiting for the moment when the distant outskirts of the solar system will reveal their most ancient secrets.
If you mentally trace the path of Sedna thousands of years forward, it becomes noticeable how unusual its existence is, even by the standards of the most distant worlds. Most of the known objects in the outer solar system remain part of the dynamical system, where the influence of giant planets continues to play a prominent role. Sedna, on the other hand, moves almost in its own kingdom of gravity. Its orbit is so huge that a significant portion of its journey passes far beyond the region where Neptune can significantly affect its trajectory. This turns Sedna into a kind of bridge between the two cosmic regions. On one side is the famous solar system, with its planets, dwarf worlds, and the Kuiper belt. On the other side, a region begins that gradually turns into the enormous Oort cloud, a gigantic cluster of icy bodies surrounding the Sun at distances that are difficult to grasp. This is where many long-period comets are thought to come from.
But Sedna is located in an unusual intermediate zone. It is too far away for typical Kuiper belt objects and too close for most of the supposed Oort cloud objects. This feature makes it a unique laboratory for studying the transition region between two worlds. Perhaps this is where the answers to questions about how the farthest regions of the solar system were formed are hidden. There are models according to which the outer regions of our star system could have experienced a series of dramatic events even before the completion of planet formation. Huge masses of ice and rock were constantly moving under the influence of changing gravitational forces. Millions of objects collided and scattered in different directions. Some of them were lost forever in interstellar space. Others were thrown into extreme orbits and have survived to this day as peculiar fossils of the early era of the solar system.
Sedna may well refer to such relics. Its orbit looks like a frozen imprint of long-gone processes. Unlike the inner planets, which have undergone intense geological evolution, this distant world has preserved much more information about the ancient past. Each kilometer of its surface potentially stores information about the composition of the primordial matter from which the solar system arose. The chemistry of such objects is of particular interest. At such great distances, solar radiation is extremely weak, but its influence does not completely disappear. Over billions of years, even rare photons and cosmic rays can significantly alter the upper layers of ice. Simple molecules gradually turn into complex organic compounds. Substances containing carbon, nitrogen, and hydrogen arise in unusual combinations. It is these processes that can explain the characteristic reddish tint of Sedna's surface.
Some models suggest that much older materials may be hidden under the top layer of irradiated ice. These substances have not changed much since the birth of the solar system. If it is ever possible to study them directly, it will be possible to obtain unique information about the chemical composition of the protoplanetary disk, which existed more than 4.5 billion years ago. But the deeper the story of Sedna is examined, the more often an even larger question arises. How big is the solar system anyway? At first glance, the answer seems obvious. However, objects like Sedna show that familiar boundaries may be only a small part of a much larger structure.
Today, it is known that the influence of the Sun extends over colossal distances. Even far beyond Sedna's orbit, its gravity continues to hold on to countless icy bodies. Some of them complete a complete revolution around the star in hundreds of thousands or even millions of years. At such distances, the boundary between the solar system and interstellar space becomes blurred. Sedna is on the way to this almost unknown region. Each new revolution takes it further and further into the region where the external influences of the galaxy begin to manifest. There, it is no longer possible to consider the object exclusively as part of the planetary system. Its motion is gradually influenced by the tidal forces of the Milky Way, passing stars, and the overall gravitational structure of the galaxy.
This means that the story of Sedna is not only related to the Sun. In a sense, its fate also depends on the movement of our star system through galactic space. Over millions of years, random approaches to stars can change the orbits of distant bodies. Sometimes, such events turn out to be so significant that they completely rebuild the trajectories of objects in the outer solar system. Perhaps something similar has already happened in the past. Some calculations show that even a relatively distant passage of another star can leave a noticeable trace in the distribution of the orbits of distant objects. If this is indeed the case, Sedna may be living evidence of an ancient encounter between the Sun and one of its galactic neighbors.
This idea gives the object an even deeper meaning. Its existence becomes part of a much larger story, encompassing not only the formation of planets, but also the movement of stars within the Milky Way. Each feature of Sedna's orbit can contain information about events that occurred long before the appearance of modern planetary configurations. The further the study of such worlds develops, the more obvious it becomes that the outer solar system hides a huge amount of unknowns. There may be hundreds of large objects beyond Sedna's orbit that remain invisible for now. Perhaps there are bodies that are larger than her. It is possible that some of them have such unusual orbits that they will completely change modern ideas about the structure of the outskirts of the solar system.
And among all these mysteries, Sedna remains one of the most important. It seems to mark the border between the learned and the unknown, between a region where the laws of motion of objects are well understood, and a space that still hides traces of the most ancient epochs of cosmic history. The closer one looks at this distant world, the stronger the feeling that its true role has not yet been fully revealed. Perhaps Sedna is not an exception,
but only the first discovered representative of a huge family of objects whose existence is just beginning to be discovered. And then its mysterious orbit will turn out to be not an anomaly, but the first hint of a much more grandiose picture of the structure of the outer boundaries of the solar system.
If Sedna is indeed only the first discovered representative of a huge hidden population of objects, then we have a very different view of the outskirts of the solar system. For a long time, it was believed that after the Kuiper belt, the density of large bodies decreases sharply. However, Sedna's orbit hints at the existence of an entire region that remains virtually invisible only because its inhabitants spend most of their time in absolute darkness and at incredible distances from the sun. There may be a world of icy objects moving so slowly that their position in the sky hardly changes for many years. Their surfaces are illuminated by faint sunlight, which at such distances becomes thousands of times less intense than near Earth. Many of these bodies may be older than most of the solar system structures we know, in the sense that their matter has remained almost unchanged since the formation of the protoplanetary disk.
That is why Sedna is of interest not only as a separate object, but also as a kind of time capsule. Its composition is able to tell about the environment that existed long before the appearance of the usual appearance of the planetary system. Inside its ice, compounds formed even before the completion of the formation of giant planets can be preserved. Some molecules could survive billions of years with little to no change. Nitrogen plays a particularly important role. At such distant objects, it can be frozen for huge periods of time. However, even extremely weak heating can cause its slow evaporation. If in the past the orbit of Sedna was slightly different from the current one, the processes of loss of volatiles could noticeably change the appearance of its surface. Perhaps it was once much lighter, and today's reddish hues appeared only after billions of years of exposure to cosmic radiation.
There is another intriguing possibility. Some models suggest that there was an exchange of matter between neighboring young star systems in the early solar system. Under dense star cluster conditions, individual objects could move from one system to another. If such processes did occur, some of Sedna's matter may have origins different from those of most solar system objects. Such a hypothesis remains extremely bold, but its very possibility shows how unusual this distant world is. Sedna forces us to consider the history of the solar system not as a completely isolated process, but as part of a larger history of star formation in the galaxy.
As it moves away from the sun, Sedna finds itself in an area where forces begin to manifest that have little effect on the inner planets. Galactic tidal effects are extremely weak, but over millions of years, even they can gradually change the orbits of distant objects. This means that Sedna's trajectory is not completely unchanged. It slowly evolves under the influence of factors that are almost imperceptible at shorter distances. On even larger timescales, its fate becomes tied to the future of the sun itself. After billions of years, the star will begin to undergo profound changes. Its outer layers will expand, and the structure of the solar system will begin to rebuild. For the inner planets, this will be an era of dramatic transformation. But Sedna will be so far away that catastrophic processes near the sun will appear to it only as a change in the gravitational balance of the system.
As the sun begins to lose some of its mass, the orbits of distant objects will begin to expand. Sedna will gradually go even further into the interstellar darkness. Its path will become longer, and the period of circulation will increase. Some objects in the outer solar system can completely free themselves from the sun's gravity and go on a free journey through the galaxy. It is possible that one day a similar fate awaits Sedna.
After many billions of years, it can turn into an interstellar object that no longer belongs to any star system. Then its endless journey will continue among the stars of the Milky Way. But while this moment remains incredibly distant in the future, Sedna continues to keep her secrets. Each new analysis of its orbit raises questions that have not yet been definitively answered. Why is there such a sharp boundary between its trajectory and the orbits of many other trans-Neptunian objects? Why did her path turn out to be exactly like this? What events in the early history of the solar system left this mysterious imprint? Some researchers view Sedna as evidence of the ancient migration period of the giant planets. Others attribute its existence to the impact of an unknown massive planet. There are hypotheses about the influence of passing stars, and even about the consequences of processes that took place even before the final formation of the solar system. Interestingly, none of these ideas yet fully explains all the observed features.
That is why Sedna remains one of the most valuable objects for studying the external boundaries of our system. It doesn't just expand the map of known worlds. It shows that beyond the usual cosmic environment lies a much more complex and ancient structure. This distant object seems to be moving in absolute solitude, but in fact, its history may be related to the birth of planets, the evolution of the galaxy, the movement of neighboring stars, and processes that took place billions of years ago. In one unusual orbit, traces of many cosmic events are intertwined.
And the deeper the understanding of Sedna becomes, the more strongly one amazing thought is felt. Perhaps the true scale of the solar system is still unknown. Perhaps the most important discoveries are not near planets that have been studied for a long time, but far beyond them, in icy darkness, where a reddish world slowly moves, completing one revolution around the sun in a time many times greater than the entire recorded history of human civilization. And as Sedna continues her journey through the silent expanses of space, she remains one of the most mysterious reminders that the boundaries of the known are still very far away.
Sedna continues her journey in absolute silence. Its orbit is so huge that human history takes only a tiny moment compared to its single orbit around the sun. While epochs change on Earth, states arise and disappear, and the appearance of civilization changes, this distant world barely perceptibly moves along its trajectory through the icy darkness of the outer solar. That is why Sedna remains more than just another object on the outskirts of our cosmic home. It is a reminder of a time when the world we are used to did not yet exist. In its orbit, there seems to be an imprint of events that occurred more than 4 billion years ago. Each of her movements is connected with the trees.
But the more is known about Sedna, the more clearly another thought appears. Perhaps its main mystery is not on its surface and not inside its depths. Perhaps it is hidden in the surrounding space. This distant object may be only the first discovered member of a huge family of worlds that still remain invisible among the endless distances beyond the orbit of Neptune. If this is true, then the biggest discoveries about the outer solar system are yet to come. There, in the cold darkness, there may be unknown planets, ancient icy bodies, and entire regions of space that remain beyond observational capabilities. Sedna seems to indicate the direction to these mysteries. Its unusual orbit reminds us that the history of the solar system is much more complex than it seemed until recently, and its true boundaries may extend much further than familiar maps.
And as this reddish world slowly moves along its endless route, it remains one of the most mysterious objects known to mankind. Amidst the icy void and colossal distances,
Sedna holds evidence of the birth of planets, traces of ancient gravitational catastrophes, and perhaps hints of the existence of something not yet discovered. This is its amazing feature. Sedna does not give ready-made answers. She asks questions. Questions about the origin of the solar system, about its true size, about the events that took place in the earliest epochs of its existence. And each new fact makes these questions even deeper. Where does the solar system end? How many unknown worlds lurk in the darkness beyond the known planets? What secrets do the farthest regions hold, where sunlight comes after many hours of travel through space? So far, there are no answers. Therefore, Sedna remains not just a distant ice object, it remains a symbol of the unknown, a symbol of the fact that even near us, within our own star system, there are still territories that can change ideas about the origin of planets and the structure of the cosmos. And somewhere far away, in the middle of an almost eternal night, this ancient world continues its journey, slowly, silently, through billions of kilometers of emptiness. It continues to preserve the history of the distant past and at the same time point to the discoveries of the future. This means that the mystery of Sedna is far from over. Perhaps its most important secrets are just beginning to be revealed.